metal displacement reactions. So these are redox reactions. So these should be arrows. Okay. So on one hand, we have an oxidation of zinc to zinc 2+, and on the other hand, we have a reduction of copper 2+ to copper solid. And that's actually what's happening in this image, is that this black stuff is the copper solid. Okay? And that solution is a bunch of ions. Okay? So I'll have copper ions and zinc ions. Okay? So when I put a piece of solid zinc in a solution of, for example, copper sulfate, I will have a spontaneous reaction where I get copper solid built up on the surface of the zinc. Okay. So how that works is a thing called the activity series. Okay. And the activity series allows us to determine spontaneous reactions. Okay, will a reaction happen all by itself? All right, and in some cases yes, and in some cases no. The way to tell is if solid metal is higher on the table than the ion it's with. Okay, so in the case of solid iron with nickel ions, find the metal on the table. That's the iron. And is it higher on the table than the ion? That would be the nickel 2+. Then yes. Okay? And that's sort of what this red and green crisscross thing is showing. Right? So let's do a little bit of practice. Okay? So based on the activity series, which of these metals will react with aqueous nickel chloride, nickel 2 chloride? So I would have a formula that looks like this. And it's aqueous, so nickel 2+ plus Cl-. So this is what we're looking for. All right, so let's find our nickel 2+ on the table. And it's sitting right there. So which of these metals will react? Anything that's higher on the table. So the metals that are higher on the table. Okay, solid metals. So barium. Barium's higher up, so yes. Chromium. Let's find chromium. Chromium is higher up, so yes. Tin, Sn. Where is it? Tin is right here, just below, so no. If the metal solid is below the ion, then it will not react. Copper. Copper's right here. It's lower down, so no. How about aluminum? Aluminum is sitting right here, so it's higher up, so yes. And how about gold? Gold is down here, very, very bottom of the table, so no. Right? But the moral of the story here is that when you want to decide whether a reaction will happen, find the ion, and if the metal is higher on the table, the reaction will happen. All right, let's complete each metal displacement reaction. If no reaction occurs, write no reaction. So let's decide first whether a reaction will happen before we bother trying to put things together. Okay? So, but first of all, we're going to do, if a reaction happens, we're going to do a single displacement reaction, right? But let's decide first if something will happen. So, cobalt bromide, we're going to be looking for cobalt ion. And in part B here, we're going to look for zinc ion. And in part C, we're going to look for chromium ion. Okay? And then these are the solids, metal solids. So remember, if the solid is higher up on the table than the ion, a reaction will happen. So in our first one, we find cobalt ion is sitting right here. And if the metal is higher on the table, then a reaction will happen. Right? So zinc will react with cobalt ions. So we're going to do a double displacement. So we end up with zinc with the bromine plus cobalt ions. And zinc is a 2+, so bromine has to have a 2. Okay, so let's look at B. So we're looking for zinc ions. And is cobalt higher up on the table? And the fact is no. So no reaction. All right, and let's look at C. So chromium ions. So chromium with aluminum. And aluminum metal is higher on the table, so a reaction will happen. So aluminum makes a 3+ ion, so I'm going to have aluminum nitrate, that's a 3, plus chromium 3+ ions. And let's see if we were right. Okay, reactions of metals with acid and water. So we've already been through this in the previous chapter, that when we have a metal reacting with an acid, we get a hydrogen gas. Okay, that part has not changed. What's different now is that we are paying attention to the fact that this is a redox reaction. Okay, so if we go through this, we will find that this nitrate ion is the same on both sides, and the nitrate ion will not change oxidation state. So it's basically a spectator. So we're going to leave it out of our equation. All right. So based on the activity series, which of these metals will react with hydrochloric acid? So basically, we're looking for things that will react with H+ ions. Okay, because that's what hydrochloric acid makes. In our previous chapter with acids and bases, we talked about how hydrochloric acid comes apart into H+ ions. So we're looking to see which of these metals is higher up on the table than hydrogen ions, right? So let's find our hydrogen ions, and they are sitting right down here at that level. So let's see about zinc, right? Zinc is higher up, so it will react. Aluminum is higher up, so it will react. Lead, let's find lead. Lead is just barely higher up, so it will react. Copper is just below, so it will not. Barium, close to the top of the table, definitely going to react. And gold, way down at the bottom, will not react. Right? Incidentally, this group of elements down here at the very bottom of the table, copper, silver, platinum, and gold, are often referred to as the noble metals, right? Mostly because they don't react with many things, and the activity series is Y. So this is why gold does not tarnish, and silver will tarnish, but it won't react with many things. Platinum is almost impervious as well. Copper holds up really well under time as well. So these metals don't react with much because of their place on the activity series. So that's why we make things like jewelry and precious things out of these fancy metals, not only because they're pretty, because they hold up under time. They don't react with much. They don't oxidize. Okay. Right, so reaction of metals with acid and water. Okay, all of our alkali metals, lithium, sodium, potassium, remember the video that I showed you all in class at the beginning of the semester? They react very badly with water. They also react badly with steam and acid. Now the earth metals, magnesium, calcium, barium, that second column, the alkali earth metals, they don't react so much with liquid water, but they do react badly with steam and with acid. Most of the transition metals will react with acid. And then our precious metals, like I was just talking about, those noble metals, don't really react with much at all. So let's identify the reactant that will react with solid nickel. Okay, so in this case, we want to pay attention to the ions. Okay, so we're looking at potassium ion, zinc ion, silver ion, barium ion, chromium ion. Okay, so solid nickel is sitting right here. So which ions are lower down on the table? So potassium, let's find potassium right at the top. Okay, potassium ion is above the metal. In order for reaction to happen, the metal has to be higher. So potassium will not work. Zinc, higher up, will not work. Silver. When the ion is lower on the table than the metal, that's a possibility. Barium, the ion is higher, so no. And chromium, the ion is higher, so no. So our answer is silver nitrate. Will react with solid nickel. But remember, if the solid metal is higher on the table than the ion, reaction will happen. Okay. So the trick is to identify the ion, right? And we're talking about the positive ions. We want to know about the metal ions. We don't care about the nitrates. The nitrate was the same in every multiple choice. All nitrate ions, okay? So we're concerned with the metal ions. And if the metal ion is lower on the table than the solid metal, then we will have a reaction.